So let's get started with, get out of here. Let's get started with some examples so you can see what this looks like. Let me undo all of this. Clear, boom. Okay. So today we're going to go over 3 examples because there are so many examples that I could go over with you, but I don't want to overwhelm you with the 5 million things that could happen. But I'm going to try to give you a broad sense of what could happen when you're doing substitution. So our objective again today is I can solve a system by substitution. So just a reminder, again, you can write this down. If you want to start writing this down, I would write these things down. Just a reminder that the point of all of this is we are trying to find where the 2 lines intersect. So this is the whole idea. So our answer is going to be a coordinate point. So our final answer is going to be x comma y. That is the whole goal. We're trying to find out where these 2 lines are intersecting. When we substitute, at least one of those equations needs to be by itself. So either you need to have a y equals or an x equals. You can't do substitution unless you have one of the variables isolated. Okay, so you'll notice today that you'll at least have one variable isolated. Okay, with that being said, let's go over the steps. So the problem is that there are a lot of different ways that the substitution can be presented. So I tried to just give you like a checklist. So first says if both variables are isolated. So if they are both isolated, which if you look down at example 1, notice how I have y equals and y equals. So I have 2 variables that are isolated. All I have to do is just set them equal to each other and solve, not solved. So y equals x plus 1 and y equals negative 2x minus 2. So what that means is I'm going to take this right here and I'm going to perform a substitution. So if y equals negative 2x minus 2, I'm going to take that and I'm going to replace it with the y up here. So I'm going to take this y out and basically just put this whole box, that whole piece of information in that y's place. So if I rewrite this equation, I'll have negative 2x minus 2 equals x plus 1. So you can see all I did was this first step up here that I suggested to do, that I just set the 2 equations equal to each other. So if y is equal to x plus 1 and it's equal to 2x minus 2, then they have to be equal to each other. So that is how I started the problem. Okay, stop me if I'm going too fast. You're like, what in the hizzle are you doing, Miss Swinsky? All right. We don't have to worry about this step right here because we already did the first step, and so we already substituted. So we're going to ignore this right here. But now we're going to pop down here to the last step. So substitute, oh wait, we have to solve the equation. That is step number 2, is solve the equation. So we're going to solve this for x. So I'm going to go ahead, I'm going to add my 2x over here. I like to make my negatives positive. You could have gone the other way. You could have subtracted the x over, it doesn't matter. So I'm going to have negative 2 equals 3x plus 1. Then I'll subtract my 1. And I'll have negative 3 equals 3x. I'll divide by 3. And then I'll have my x equals negative 1. Okay, so just to recap, I set them equal to each other, and then I solved for my variable. I solved for x. Now, the last step, remember our whole point is that we are trying to find the coordinate that they are intersecting at. So I still need to find y. I have my x, but I don't have my y. So I'm going to take this answer and I'm going to plug it back in to one of these equations over here. It absolutely doesn't matter which one you plug it into. I'll show you right now. You can plug it into either one and you would get the same answer. So if I plugged it up into this one, and instead of an x, I put a negative 1, I would have negative 1 plus 1 equals 0. If I plugged in the negative 1 to the bottom one, I would have negative 2 times negative 1 minus 2. So that gives me negative 2 times negative 1 is positive 2. 2 minus 2 is 0. Okay, so you don't have to do that for both of them. I'm just showing you whatever you pick is going to work. So my final coordinate point where they intersect is negative 1, 0. Okay, so if you were to go graph these, you would find that they intersect at negative 1, 0. Okay, how are we doing so far? Any questions, problems, concerns? Okay, that is just one type. So that is if the y's are equal to each other. That's one type of substitution you might have. All right, I'll give you a few seconds to copy this if you're not done yet, and then we will move on. I have 2 more examples to show you, and then we're going to hop on to the whiteboards. All right, let's move it on here. Mouse. Come on. Okay, clear this out. Okay, number 2. So back on the steps, if I back these steps up here, the first step was if they both equal the variable, set them equal. So you can see here in example number 2 that we only have one of the variables isolated. So see how the top one is not isolated, but the bottom one is. That's okay. We're just going to do a different type of substitution. We're still going to substitute. It's just that we can't just plug them equal to each other. Now, if you're like, you know what, Ms. Winsky, I just want to isolate this y and go ahead and set them equal, you absolutely could do that if you wanted to. But I'm going to show you a different method that might be a little bit easier and less work. We always like less work. Okay, so get back. If I have one of them set equal, I'm still going to do the same idea of the substitution. So y equals 7x minus 6. So what I like to do is I like to circle or just box in what am I going to substitute. Y is equal to 7x minus 6. So that's what I'm going to plug in, and I'm going to plug it in to my top equation, just like I did in the last problem. Okay, so I'm going to plug it in for the y up here. So basically, I'm taking this y and I'm taking it out. I'm getting rid of it, and I'm putting the 7x minus 6 in its spot. So here's what it would look like when you plug it in. I'm going to take this top line. I still have 7x. I have a minus sign. And then I have this whole chunk of y that I'm plugging in. So since it's a big chunk, I'm going to put it in parentheses because I'm plugging in that whole piece of information. And then continue to write the problem. So again, all I did was take that y, I took it out, and then I put in this box of information in place of the y at the top, a substitution with the whole equation. Crazy. Now, all I have to do is solve for x. Okay, so with this, because I have a minus sign in front, I have to distribute that minus sign. Always doing too much, right? Math is always doing too much. Okay, so when I distribute this minus sign, I'm going to end up with 7x minus 7x plus 6 equals 6. Now, as I start to solve this, look what happens. 7x minus 7x cancels, right? That's a 0x. So all I have left is positive 6 plus 6 equals 6. What in the hizzle is going on here? I have my x's canceled. Now I have a 6 equals 6. So let me tell you, let's see if you remember this. Let me put a text box in here. Okay, if your variables cancel out, that means that we have a special situation. So first, you want to ask yourself, is the statement true? So is the statement that I have left, 6 equals 6, is the statement true? So does 6 in fact equal 6? I think we can all agree that yes, 6 equals 6. That is true. So if the statement is true, your answer is infinite solutions. Infinite solutions. I'm not sure if you remember what that means, but infinite solutions means that these are the exact same lines. So if I were to solve for y up here, I would have found that I would have gotten the same equation, y equals 7x minus 6. So what this means is that these lines are exactly the same. And so where do they intersect? They intersect everywhere. There's not just one point, they intersect at every single point possible. So infinite solutions, let me come back to here. Infinite solutions, go back, abort. Go back to my text. Okay, infinite solutions. And these lines are the same. Okay, what happens though if the statement is false? So what happens if I would have done this and I would have gotten 3 equals 6? Anyone know what that means? What would it mean if it's false? Any ideas? Remember, what's the point? What are we trying to figure out here? Oh, I see someone's cashing in. Someone's cashing in. Hey, yes, Mila, good. It means that there's no solution, right? So if there's no solution, what does that mean about the lines? What does it mean about the lines? If there's no solution, you are absolutely correct. Yeah, buddy. Okay, we're getting it. Good. That means that these lines don't intersect, which means they are parallel. Good work. Okay, so this problem here, number 7, this is an infinite solutions. Okay, so you would write infinite solutions. There is no intersection because they intersect everywhere. Now, this is the difference between algebra 2 and honors algebra 2, because algebra 2 does not go over these specific special cases, but honors, you guys get to know all this fun stuff. I know you're like, yay, great, I'm so happy, woo, yippee. All right, I can tell the excitement in the room. Here we go, let's go on to the last one. So the last one is not going to be special, it's just another type just to make sure that we actually understand and we get a solution. Okay, so this is just like number 2. Just want to do one more example with you. So as you can see, this time they gave us x is isolated. So this time we are going to insert the negative 2x minus 1, because now the x is isolated. Up here, the y was isolated. It doesn't matter which one, but we'll use the one that's isolated. So we're going to take the negative 2y minus 1, and this time we're going to plug it in for x. So we're going to take this and plug it down here into the x spot. So that means this x here is going to come out, and we're going to put that whole equation, negative 2y minus 1, in its spot. So here's what it will look like when you substitute. So that 2 is outside there. You got to keep the 2 there, but then you will multiply the 2 by that whole box that I circled. Then continue on, plus 3y equals 0. Okay, once you make that substitution, it's all algebra from here. So we'll distribute that 2 into both of these. So it'll be negative 4y minus 2 plus 3y equals 0. Okay, we'll combine our like terms. So negative 4y plus 3y gives me a negative 1y minus 2 equals 0. I'll add my 2. So I'll have negative 1y, bring it over here, negative 1y equals positive 2. And then I have to divide by negative 1. I won't go all through that step. So now y is equal to negative 2. Okay, don't forget, we are trying to figure out where do they intersect. So I have to find my x. So here's my y. I'm going to take my y and I'm going to plug it back into, I always plug it back into where I started with my box because it's already equal. So I'm going to take this y out, and I'm going to put in a -2 in its spot. Just substitute that right in. So -2 times -2 will give me a +4 minus 1 equals 3. So my intersection, my final answer is 3, because that's my x, 3 comma y of -2. That's 2 for all you non-Spanish speakers in the house. So trace comma -2. I don't know what negative is in Spanish, but you know, I made an effort. Okay. So guys, let's see how we're feeling about this. I'm going to have you practice. What we're going to do, either on your phones, we got about 15 minutes, so we're going to do some practice for this last time. So if you want to use your phones, I would suggest that is the easiest thing. If not, you can always open up a new tab. I'm going to drop in whiteboard.fi. So you can either click on that if you're going to use your computers, you can use that. Or if you want to just pull up a new screen on your phone and type in whiteboard.fi. And